This is the pre-calc lecture for lesson 89. So today we're learning about ellipse. I think we already learned a little bit about ellipses previously. You should notice that the equation looks just like a hyperbola, except for that there's a plus sign in between. And so these are nice pictures here. You'll notice that the longer axis they call the major axis, and then this one would be the minor axis. You'll notice that when the major axis, when x is the major axis, x comes first, or x is over a, and then when y is the major axis, then the a, basically a is the larger of the two numbers. Of a and b, a is the larger of the two numbers. So, like this one that's shaped this way. Oh, you can't see what I'm saying. This one that's oriented this way, the bigger number, the a, that's like a bigger distance right there, is over, it goes with the y. Okay. Sometimes they'll even, I've seen it where they'll have the y squared over a squared first, but it seems like we're going to stick to this plan right here. You may or may not have already known that the definition of an ellipse is that the sum of the distance, like there's two, ellipses have foci, they have two foci, unlike a parabola that just has the one focus. The sum of the distances from any point on the ellipse to the two foci is constant. Or in other words, you know, d1 plus d2 always equals the same, no matter, see, this is supposed to look like a picture of a piece of string, and they're moving it around the ellipse. Okay, so the sum of d1 plus d2, no matter where I move this around the ellipse, is going to remain constant. Okay. We have, you probably know what a is, because remember the equation of the ellipse was x squared over a squared and y plus y squared over b squared. So you know what a and b are. C is, well, I like to think of C as the distance between the center and the focus. So in this case it'd be right here, the center and the focus. C is the distance between the center and the focus. And so you'll notice that there's this relationship. If you look at this triangle right here, there's this relationship that a squared is kind of like a is the hypotenuse now. Kind of like Pythagorean theorem, but the letters are kind of messed up, huh? So, but you're just going to have to deal with that. A is now the hypotenuse. And so it turns out that a squared equals c squared plus b squared. That you need to know that relationship when you're doing these problems, so that you can solve. Sometimes they'll have you solve for an unknown or write the equation of the ellipse, and they don't give you all the information, so you have to use this relationship here to find either A or B or C. Okay, so I think all that there is left for me to do is probably just show you how to do one. So we'll do that. So the one that they have us doing is 89, number 8. It's almost always number 8. So it says an ellipse has vertices. I'll write it down on my paper first. I know you can't see what I'm writing, but then I'll put it up here where you can see it. 89, number 8. Has vertices at 0, plus or minus 7, and foci. And I say foci, but I think we might want to say foci, because I've seen, you know, others call it foci. It might be that there's two different ways to say it, but just know I'm going to be saying foci. Write the equation and graph the ellipse. So I need equation and graph. Okay, there, I wrote it all on this paper. Hopefully you can see that pretty well. So since I have to do the graph anyway, I'm going to go ahead and give myself a graph. Okay, so 0 and then plus or minus 7. So this one obviously has this is going to have a center probably at the origin. The authors of the book are nice about starting you out easily, but you should know that we can do transformations on this, you know, with the x minus h and y minus k and all that business. That can happen with ellipses. You can have a center that's not at the origin, but in this case, it looks like our center is at the origin. Now, the foci are always going to be on the major axis. I don't know if I mentioned that before. So this is going to be an oblong looking, I don't know if that's the right way to say it, ellipse. So 3, 4, 5, there's a foci right there. Right there. Now, I don't know how wide it is yet, but I know that this has got to be the major axis. So I know that, you know, however far it goes out to the right and left, it's going to be less than 7. Now I know I'm going to want to find out what A and B and C are. So, and what did we just say? We said, the book just told us, and they showed us that picture of that triangle, that A squared equals B squared plus C squared. Now C, I think I told you, C was the distance between the foci and the center. So I can just look at that. It looks like it's 5. So I think C is 5. And this is the major axis. So I'm going to, it's the longer axis, and that's going to be A. We use A for the major axis. So A is going to be 7. We don't know what B is, but it's not too hard to figure it out because we have this formula right here. So A squared, that's 49. And B squared, we don't know what that is yet. And C squared is 25. And so 49, I got to subtract 25 from 49. And we get B squared is equal to 24. So that means B must be root 24. Now root 24, you could write that as, you know, 24 is 4 times 6, and you could write it as 2 root 6. I can say, or 2 root 6. But the way I'm going to put it in my equation, well, no, actually, I kind of want to get a decimal for that, because I need to graph it still. I don't know exactly where on my graph root 24 is. 1, 2, 3, 4, 5, 6. I'm going to find out what the square root of 24 is by asking my calculator. Turns out it's about 4.8. It's about 4.89, 4.9. So I'm going to write it as being very close to 5 as when I draw it on my graph. So 1, 2, 3, 4, 5. So it's somewhere in there. 1, 2, 3, 4, 5. I just wrote all that down. So now I can, it always looks like a football that something happened to it. There it is. Not the nicest looking one. What else? So I've graphed it. I need the equation now. That's all I need now. So I know that my equation is going to go x squared over something squared plus y squared over something squared equals 1. So in this case, A, the bigger number, A is the bigger number, is going to be under the y. And we already know that A was 7. So I can write it as 7 squared, or I can write it as 49. And I think your book actually wrote it just as 49. And then, so this one would be root 24 squared, which is just 24. And I think that's it. Now there's more examples in your book that you can look at. But anyway, I'm out of time. We'll see ya Tuesday.